So hydraulic modelling is the application of fluid dynamics to simulate the movement of water. We use hydraulic models to determine the extent of a floodplain and the probability of a floodplain occurring. We use hydraulic models to simulate what would happen if a dam failed. And with that information, we can determine how far the extent of the inundation goes, how fast it's going to be, so that we can prepare evacuation maps and emergency action plans. The biggest advancement I've seen in hydraulic modelling over the last 10 to 15 years has been the application of 2D models.
Yeah, two-dimensional models have been around for over past, I'd say, 15 to 20 years. And the real problem that consulting firms and municipalities weren't using the modeling software is because the computational resources to run a model, they just weren't available at the time. They weren't economical.
The only thing a 1D model really calculates is how deep that water's going to get. It doesn't determine the direction. That is really down to the engineer to actually determine which direction that water's going to go, which is easy in most places. Certainly in mountainous areas, it goes downhill, confined within the embankments of a valley. And so although the 1D may be suitable in most places where you've got steep terrain, the 2D modelling can be very useful in areas where the flow patterns are very irregular. Whether it's out in the Central Valley of California where you've got a big alluvial floodplain with a lot of levees and unconfined flooding. Down in Florida where it's a bunch of interconnected swamps, very unconfined flooding where the water essentially goes in every direction because it's so flat. In a highly urbanized area, in a city centre, you're going to have flow going around buildings and through roads. That's where a 1D model is very challenging.
Now, the issue with using a 1D model to display and compute velocities is that you must interpolate the velocity from cross-section to cross-section. A subdivision, for example, you'll be able to calculate the velocity at one particular house, but you won't be able to accurately predict the velocity at your neighbor's house. Now, in a 2D model, we can accurately predict the velocity at each individual structure. So not only now are we showing the depth and the impact to the structure, we're also more accurately showing the velocity. And in a lot of scenarios, most of the damage can be done in very low depth but high velocities.
One of the pieces of software that I'm particularly excited about is the HEC Raise 2D. So HEC Raise is the river analysis system developed by the US Army Corps of Engineers Hydrologic Engineering Center. And one of the advances of this is it uses a new finite volume method, which is a very efficient way to process the terrain data and run the simulation. So we've used it extensively. We've performed canal break simulations, dam break simulations, urban flooding simulations, overland flooding from combined sewers, and it's provided a very, very efficient way to simulate these things that typically were just too complex to model efficiently using 1D. And that's where using 2D models has allowed us to simulate that much more efficiently and with a much greater level of accuracy and confidence. And the real benefit to our clients is they're going to get a much more advanced, a much more defensible model, yet the level of effort can be significantly reduced.